Right, so we learned yesterday how to write names and formulas of type 1 ionic compounds, so a metal or nonmetal, and that metal happens to not be a transition metal. But what happens when the metal or the cation is a transition metal that requires the stock system? So if you recall from before, some of our, or many of our transition metals, so we'll fill that in right here, can form more than one charge. And we call these metals that can have more than one charge multivalent, meaning they can have multiple valence electron arrangements. When that happens, we have to use what is known as the stock system. So this is the system that has been adopted through, for most chemistry labs around the world to specify which form of charge the transition metal has. So that could be, there's elements or metals that have +1, +2, +3, or even +4. Some of you either go up to like 7 or 8 positive on that metal ion. So we're going to use Roman numerals to show the charge on the cation, and that cation is going to be a metal. Okay. So how do we know if it's a stock system metal? It's going to be one of the elements that's a transition metal. That does not include zinc, cadmium, or silver. We mark those on our periodic tables with the charge because those are monovalent metals. And then including tin and lead. So we put a little S in tin and lead's blocks on the periodic table so we know which ones we're using a stock system for. Or we're going to need the stock system when we need to communicate the charge on a multivalent element. Okay. And that keeps everybody on the same page. We're all using the same system. So we're going to put multivalent elements or metals that we need to be able to say what the charge is going to be. All right. So if we're given the name and we need to write the formula, this is actually the easiest chemical formula writing that we have of ionic compounds. So when we look at the name, I can tell that this iron has a +2 charge. The Roman numeral tells us the positive charge on that metal. Remember, metals are always cations, so this 2 is going to tell us that it's +2. So I don't have to look up the charge on iron on the periodic table because the Roman numeral right here tells me that this is going to be a +2 charge. So when we write the formula for it, I'll write the symbol for iron like we've done before, and I'll write the charge of it, and I get that from this polyatomic, or from this Roman numeral over here. And then sulfide is just sulfur, and if I look at my periodic table, I'll see it's in group 16, so it's going to form a -2 charge. And then this is where we crisscross. So I'm going to take the 2, I'm going to put it over here as a subscript, and I'm going to take this 2 and cross over here as this subscript. So we get Fe2S, 2. But these 2's are reducible. I can divide both of those by 2. So my final answer is just FeS. So the chemical formula for iron 2 sulfide is FeS. Now if I do the same thing with tin-4 fluoride, tin-4 is going to have a +4 charge. So tin has a symbol of Sn. It is +4 here. Fluorine is a halogen, it's -1. So we're going to crisscross our charges and we get SnF4. Okay. And that cannot be reduced any further, so that we're going to end there. Now nickel-3 oxide, nickel-3 is +3. So Ni with a +3. Oxygen is -2. We're going to crisscross these, so we get Ni2O3. I cannot reduce that any further, so that's my final answer. Okay. Titanium 3 nitride, so again, titanium has +3. That's what the Roman numeral is telling me. And nitride is just nitrogen, and it's -3. Now when I crisscross these, I'm going to get Ti3N3. These 3's both reduce to just 1 and 1. So my final answer is Ti for titanium and then a capital M for nitrogen. Okay, so when you have a Roman numeral, that tells you the charge on the cation. It does not tell you the number of atoms of metal. It tells you the charge on the metal. And that's one of the biggest mistakes we tend to make. Okay, so down here we're going to write the name. Now this gets a little more complicated because I have to figure out what the charge is on my stock system metal. So when I see this, I'm going to read this Fe2O3. Fe is iron, and I'll look at my periodic table and see that iron is a transition metal. It's not one of the exceptions, so I know I need a Roman numeral to report the charge. I'm going to write iron, and I'm going to leave some parentheses here. I'm going to go ahead and do that to remind myself I need to go back and figure out what the charge is. And then this oxygen just becomes oxide like we've done before. Now I have to figure out what the charge is. I don't know the charge on the iron. I have to calculate that, but I will always know the charge on my negative ion. So oxygen is always -2, and there are 3 of them right here. So I have 3 ions of oxygen, each with a -2 charge, for a total of 6 negative charges. Now for an ionic compound, when I have 6 negatives, I also have to have a total of 6 positives. But there are 2 iron atoms. So I'm going to take those 6 positives and divide it by the 2 iron atoms, which tells me that each iron is +3. 3 positive times 2 is +6. 2 negative times 3 is -6. So the only charge that this iron can have, if there are 2 of them in the formula, is +3. So that will become my Roman numeral. Okay. Now the next one we have strontium. Strontium is in group 2, so therefore it is not a stock system metal. So I'm just going to do this the way we did it before. So I'm going to write strontium, and I do not report the charge as a Roman numeral because it's not a stock system metal. And I'll change the ending of fluorine to fluoride. Okay. Next we have gold. And gold is a stock system metal. It's a transition metal, and it's not one of the exceptions. So I'm going to write gold, and since I know I need the stock system, I'll write some parentheses because I know I'll have to fill in a Roman numeral there, and chlorine becomes chloride. So now what I have to do is use my negative charge to figure out the charge on gold. Chlorine is a halogen, so it's -1. So there's 2 negative charges total. I'm going to flip that to a positive because I know I have to have a total of 2 positive charges to balance the -2 for the total chlorine. There's only 1 gold in the formula, so +2 divided by 1 tells me the charge on the 1 gold ion is +2. So this is gold 2 chloride. Now copper here is a stock system metal, so I'm going to write copper. I'm going to leave parentheses, and then bromine is going to become bromide, like we've done before. Now I have to figure out what the charge on copper is. Bromine is always -1, and there's 1 of them, so I have a total of 1 negative charge, which means I need a total of 1 positive charge. There's only 1 copper atom. So +1 divided by 1, copper 1 bromide. Okay. So there is an algebraic way of solving for the charge of your cation. Remember, you will always know the charge of your anion. So the way I showed up here is by using your negative and flipping that to a positive and then dividing by the number of cation atoms. The algebraic way is another way of doing this. So if I was going to do Fe2O3 like we did at the top, algebraically I would say, okay, I've got how many cation atoms? Well, I've got 2 of those because there's 2 iron atoms. But I do not know the charge on iron, so I'll plug that in for X. Plus, the number of my anion atoms is 3. and I do know the charge on oxygen is -2. So this has to add up to 0 because all my positive plus all my negative has to add to 0. So I have 2x minus 6 is equal to 0. Move my 6 to the other side, and I get, I'm going to come over here, 2x is equal to positive 6, divide by 2. The charge on the cation, so that's what I'm solving for right here, is equal to positive 6 divided by 2, positive 3. Okay, so that is the charge on iron. So when I write the name, it'll be iron 3 oxide, which is the exact same thing that we got up here in this first one. Okay. So what we're going to do is some practice on the next page. So you're going to be writing the formulas over here, keeping in mind that this 2 on this cobalt 2 chloride is the charge on cobalt, not the number of cobalt ions. Okay, so this is not the subscript, this is the charge on cobalt. Use that and then crisscross. On the left side, you're writing the name. So this is where you have to look up the charge on your anion. It's -1. There's one of them, so I have one negative, which means I have to have a total of one positive, which means that copper has to be +1. Okay, so you can use your negative ion to figure out your positive and then divide by the number of metal atoms, or you can use the algebraic method like I showed before. Okay, so you have page 7 to complete at this point.